Hi, my name is Chris Alexander, and today, as part of the ADV Connect training series, I'm going to talk to you about composite repair technologies, and I'm going to provide an overview and kind of a historical perspective. And I'll be brutally honest, this is probably my favorite subject in the whole world, partly because I've been doing it for a long time. So this is kind of an overview of what we're going to talk about in this particular training course. We're going to talk a little bit about, what are composite materials. I'm also going to talk to you about all the things that we're going to talk about. We have 10 videos that are going to make up this particular segment of the ADV Connect training course series. I'll give you a little historical perspective about composites, but also specifically in the pipeline industry, how have we used composites? We'll talk a little bit about what defects and features can be repaired. And once again, this is an overview, so I'm not going to do a deep dive. If you hang in there, we'll talk about some of these very specific things, and we'll have a training course on each particular defect. And then I'm going to talk to you a little bit about some of the ongoing efforts. I've been doing composites for a long time, and my guess is until I quit working, I'm going to still be working on composites. So we'll talk a little bit about joint industry programs that we call JIPs, and then we'll talk about a kind of a user group we put together called the Composite Technology Advancement Group, or CTAG. I really like acronyms, so anytime I can make an acronym out of anything, I'm going to do that. And then we'll kind of wrap up with some closing comments. So this is kind of a list of all the things that we're going to talk about. And, one of the things that we could have done is we could have created a 3-hour training class and you could have gone to sleep 3 times. We just didn't want to do that. So there's an advantage in what we're doing with ADV Connect is we're breaking these very complex subjects into small bite-sized chunks. And so, most of these will probably be 7 to 12 minutes. And it allows you to sit down during lunch. If you're eating a peanut butter sandwich, it's like, hey, I want to watch a couple of these. Or if you're on the road and you got your iPhone, you can watch these. So here's the list. I'm not going to read through all of them. But, a couple things is like one of the topics we're going to talk about is the design basis for composites. How do we make sure composites are good for the long haul? So we'll talk about some of those deep dives. Another subject is crack reinforcement. And pipelines have cracks. When I first started doing this back in the early 90s, I never dreamed we could use composites for repairing cracks. Today, we can do that. We've got a lot of research programs that we've done that have validated that. So that just kind of gives you an overview of what's going to be coming down the pike. I realize some of you watching this have never heard or don't know a whole lot about composites. Usually, those of us who are engineers, in class, we had some exposure. So as I said, I love composites. And, I've got a couple of things to show you. One is, what is a composite? And at the end of the day, it sounds kind of funny, but composites are basically glue and string. And so this is some carbon fabric, actually that came from my PhD. And so you can see it's stitched. And so there's carbon fibers in this particular fabric that run this way, and it's stitched together. So that's an example of a carbon. If you see black fibers, that typically means carbon. I've got some other fabrics here. This is actually an e-glass, and it's got a chopped strand on this side. And so what happens is you basically saturate these with a resin. So the funny thing is the difference between this and this is literally just adhesive. I mean, I guess if you're a redneck, you say it's just glue. But what happens is when you put the adhesive in here, this becomes extremely strong. The way we test it, though, is we make basically coupons. And so we'll take a panel like this. We cut a dog bone out, and then we basically pull on it. And this particular carbon, the tensile strength's about 150,000 PSI, which is stronger than most of the steels. As a matter of fact, for a lot of the vintage steels, this material is twice as strong as the steel. So this is something that's it's a big part of what we've done, and it's going to continue to be a really big area. Of course, I love airplanes, which is probably one reason I love composites. So composites have been used a long time. This is the French Newport, so this goes back to World War I. But in the essence, basically what the French and English and German Americans and probably even Italians were doing in World War I is they were using basically fabric, which is a composite. They used wood, and they used different adhesives, those things, to build these airplanes. So composites have been around for a long time. In the pipeline industry, it's relatively new, relative to the age of the pipeline infrastructure. So let's talk a little bit about the pipeline industry. And so I started my career in 1993, which is a long time ago. And within about the first 6 months, I got exposed to working on a product that's called Clock Spring. It's still around, and it's part of the CSNRI technology company. And so it's been my thing, as the slide says, since 1994. And, a little bit of a rabbit trail. If you're young in your career, my advice is find something you really like to do. And I heard one time somebody said is Find something you like to do and you'll never have to work a day in your life. And so as crazy as it sounds, even at 55, I do work on composites almost every day, and I probably think about them a little bit every day. So as an industry, we've been using these composite repair technologies for about 30 years. And when I was a younger version of myself, I'd go to these conferences and, guys that were about my age in their 50s and 60s, they look at me and say, hey, college boy, we're not using glue and string in our pipelines. Today, number one, nobody calls me a college boy anymore. But the bigger thing is, because of the research that's been done, we really have great confidence in these technologies. And so we're using these technologies today in a way that, 30 years ago, we never even dreamed that we could. The other thing to me that's super exciting is even within the past 6 months, there's a lot of composite repair companies that are coming on the scene. And so I was looking at a list yesterday. We've got more than 20 companies who are repair companies focused on composite technologies, which to me is really, really exciting because it's going to help innovation and for us to figure out how do we integrate these new technologies. So originally, as I talked about earlier, composites were used just to reinforce corrosion. And so that was going back in the early to mid 90s. And as we transitioned into the mid to late 90s, we started using them on dents and mechanical damage. And I kind of have a running tally. I'm reasonably good at math, being an engineer. And we've done about 2,000 destructive full-scale tests. And so we've blown stuff up, we've bent it, we pulled it apart. And so because of that vast volume of data that we've generated, we really understand what it can do. And I've got, a list of dents, mechanical damages, wrinkle bends, girth welds, cracks. And once again, remember, this is an overview, slide deck and overview video series. But in these other videos, we're really going to do a deep dive. And one of the things that's a big part of this industry is validating these technologies. And so you see in this slide here, you got an image of a pipe that's bent. That's got a defective girth weld. We do a lot of burst tests. A lot of times people say, what do you do for a living? And my response when I'm not at the airport is I blow stuff up for a living. And here's a couple of photos that just show the process of validating technology. So this is burst test. The next slide shows 4-point bending. This is actually a 30-inch pipe that had a girth weld from the 1950s that we bent. And once again, the composite technology, you can see that's a carbon. Remember, anytime you see black, that's a carbon technology. This is a wrinkle bend. And so this load frame actually grabs the end of the pipe and it will do 1,000,000 foot-pounds and it will grab the end of the pipe and it will sit there and bend it. And you can go to very high strain levels with this setup. So once again, we're going to have a whole video that's going to talk about this program that we did in evaluating several different technologies. So what's going on? So I've talked a little bit about the history. So these are a couple things that are going on. We're doing a JIP that is going to look at narrow groove corrosion. And we've got, 4 or 5 operators. I think we've got 5 or 6 technology companies who are signed up. What a JIP does is it allows you to take a really expensive, complicated problem that's probably anywhere from $500,000 to $1 million, and you get a group of people together and they put their money. So if you've got 10 companies that put $50,000 each in, you can solve a $500,000 problem, for only $50,000 each. So I think I've done about 33 JIPs. My very first one was my PhD. So like composites, I love JIPs. They are not easy to put together, I'll tell you that though. The other thing is we started this user group I alluded to earlier called CTAG, and we started at the end of 2022. We've actually had great attendance. We had a meeting earlier, a couple of months ago. We typically have 90 to 120 people that come. And so the reason that we did it is we want to bring together not only composite repair companies, but people that are doing things in the composite spoolable pipe space, have conversations. And so we meet in the spring and then we meet in the fall. Matter of fact, we've got a meeting coming up on Halloween. So that should be fun. And then the last thing that we're doing as part of CTAG is we're going to develop a pipeline composite repair standard. So there's the ASME PCC2, which is kind of the generic composite repair standard. This standard is going to be focused just on the pipeline industry. So we're in the early stages of that. So that's going to be a big part of what we're going to wind up doing this year. So kind of wrapping everything up, we're real excited you're going to be part of this journey. If you watch all the videos, I can guarantee you're going to learn some things, which is really the goal. We want to make it easy to learn. I mean, you literally don't have to leave your office. If you want to learn on the weekend, you can do that. And we want to make it easier for everybody to do that, especially people who are part of our ADV Connect platform. The work that we've done is going back to the 1990s. So for 30 years, we've really developed this technology. I think it's a great model for technologies in the energy industry, what we've done. And it's a lot of people. It's pipeline companies, it's competitors working together, pulling their money and working together. CTAG involves a lot of people that are competing against each other. The regulators are involved. And then you got, SMEs like me who really enjoy working in this industry. And the last thing I'll say is what makes it exciting for me is I've been part of the history, but I'm also going to be part of the future. And these composites are going to continue to play a really important role. Our pipelines are not getting any younger, and composite repair technology is going to play a central role in making sure that we have safe pipelines for the future. Thanks for joining us, and I look forward to your joining us as we go through this composite repair journey. Thanks.